Hello, welcome all. Myself Kiran. Today we learn about solar PV power generation, that is harnessing solar energy, and it's one of the concept in subject called RE, which is an open elective in 6th sem of engineering. Okay, let us see the outline. Overview: what is solar PV? History of solar PV, components of solar PV system, advantages, challenges, and preparing for the future. And last but is the conclusion. Okay, let us see the overview. In the next few slides, we will delve into the fascinating world of solar photovoltaic technology and its significant role in shaping the renewable energy landscape. Okay, solar PV technology stands for solar photovoltaic technology, and we'll study about this in the further slides. Okay, just remember the full form. And solar PV power generation is an forefront of the global shift towards the clean and sustainable energy resources. That is, it plays a major role in transition from non-renewable energy resources to renewable energy resources. Okay, and as a concerns about the climate change and environmental degradation continue to grow, the importance of harnessing renewable energy resources like solar power cannot be overstated. Okay, that is, in spite of bad climate, etc., the importance of this solar PV power generation has not got reduced over a period of time. Okay, and throughout this presentation, we will explore the fundamentals of solar PV technology and its historical developments, components of solar PV system, its various applications and challenges and opportunities it presents. Okay, let us see what is meant by solar PV. Solar PV, that is solar photovoltaic technology, harnesses sunlight to generate electricity. What it does is it harnesses the sunlight energy and it generates the electricity. That's the meaning of this. And PV cells, typically made of silicon and building blocks of solar panels. When sunlight hits these cells, it stimulates the movement of electrons and creating the electric current. And here they are given how the solar panels play a major role in creating electricity or generating electricity from the sunlight. That is, the solar panels are made up of silicon. Okay, and when the sunlight falls on this, the electrons in the silicon atoms get excited, and it stimulates the sunlight will stimulate the electrons to move, thereby generating the electricity. Okay, and the process begins with the sunlight, which consists of photons. When the photons strike the surface of the PV cell, they transfer their energy to the electrons in the silicon atoms of the cell. This energy excites the electron, allowing them to break them from the atomic bonds and flow through the material. As I told you that when the sunlight falls on the silicon atoms, electrons in the silicon atom get excited and they break the bonds, and that causes the electrons to move across the material. Okay, and we know that the flow of electrons is called the electric current, right? That's what happened here. The movement of these electrons create a flow of electric current, which can be then captured and harnessed for this purpose. This direct conversion of sunlight into electricity. Okay, and let us see the history of solar PV. In 1839, the French physicist Alexander Edmond Becquerel discovers the photovoltaic effect, which describes the generation of electric current in a material upon exposure of light. Okay, I will ask you one question, and any information about the Becquerel, please write the comments in the comment section. Okay, and in 1883, American inventor Charles Pettis constructed the first ever solar cells using selenium vapors and coated with thin layer of gold. Okay, in 1954, the Bell Laboratories engineers Darrell Chapin and Calvin Feller and Gerald Pearson developed the first practical silicon solar cell, which has an efficiency around 6%. Okay, and that was a great. And 1960 to 1970s, solar PV technology ceased to increase adoption in the space exploration missions powering satellites and spacecrafts. Okay, and in 1980s, improvements in maintenance manufacturing techniques lead to the decline in the cost of solar panels and making them more accessible for terrestrial applications. And let us see the components. I will explain you this in the next slides, but have a look of these pictures. Okay, that will be very helpful. And the first picture is the solar panel, the next this inverter, and the third one is support structures. Okay, for the solar panels, and the fourth one is, these are the storage structures for storing the electricity, and fifth one is the connectors, and the last one is the breakers or the circuit breakers. Okay, and components of solar PV system. First one is solar panels, also known as photovoltaic modules. Solar panels are composed of individual solar cells that capture sunlight and convert it to electricity through photovoltaic effect. Okay, and as I told you in the previous slides, the solar panels are made up of silicon and they produce the electricity through photovoltaic effect. That's what they're given here. Inverter is responsible for converting the direct current electricity generated by solar panels into alternating current. Okay, they're used because to convert the DC to AC current. Okay, and AC currents only transmitted. AC currents can be transmitted over long distance. So inverter is very essential. And mounting structures. They're nothing but they provide support to the solar panels. Okay, I will show you once again the pictures. The third picture is the supporting structure for the solar panels. Okay, and next one is storage system. Stores excess electricity for use when sunlight is unavailable, ensuring the continuous power supply. These storage systems are very essential because during the rainy season, sometimes the solar energy station may not produce the enough electricity. In that time, the energy stored in the batteries or the energy stored in the storage systems is utilized. Okay, to enable the continuous flow of electricity. And wiring connectors. These wiring connectors are very essential because they connect the components, electrical components across among the devices. Okay. And monitoring devices. They track the system performance, providing real-time data on energy production and identifying potential issues for the maintenance. Okay. Charge controller regulates the flow of electricity from the solar panels to the batteries, preventing overcharging and ensuring the battery longevity. That is, when the electricity flows from solar panels to the storage system, there must be regulator. Okay, think of it as a regulator of current. And I will give an example. This charge controller is analogous to our home TV regulator. Okay, or stabilizer. TV stabilizer is there no in the home. That is similar to the charge controller. Okay, and circuit breakers. They protect the system from the overloads and short circuits, enhancing the safety and reliability. Okay, and advantage of solar PV system: reduced carbon emission. Solar PV generates electricity without producing greenhouse gas emission. Okay, since it does not produce any greenhouse gases, the amount of the there will be no gases produced in the system when we harness the solar energy, right? So it reduces the greenhouse gas emission. And conversion of natural resources. Balancing the sunlight, solar PV reduces the reliance on finite fossils. Since the energy is extracted or electricity is produced by using renewable energy resources, there is a dependency of they reduce the dependency on non-renewable energy resources. That's what it says. Okay. And job creations. Solar PV industry creates a job across manufacturing, installation, maintenance, and research sectors, and contribution to economic growth and employment opportunities. Since to establish this solar PV technology or systems across the field or across the farm, we need people, right, to maintain these structures, all those things. Thereby it creates a job. Okay. And energy cost saving. Solar PV enables homeowners, business, and governments to reduce electricity bills by generating their own clean energy and potentially selling excess power back to grid. That is, once you have the own solar PV system installed in your home or office or in any of the buildings, you have your own electricity, right? Since you have your own electricity, the amount of electricity that you are getting from the outside is very less compared to the initial. So you are reducing the cost. That's what it says. And energy access in remote areas. The meaning of this is, suppose you're in the remote areas where there are no electric connection to the remote area where you're living. Once you install the solar PV system, you can have your own electricity, right? In those areas also, we can access the electricity using solar power plants or solar PV systems. And energy independence. By generating electricity on site, solar PV enhances the energy security and independence. Since you have their own electricity at your home by using solar PV technology, you are not dependent on anyone, right? So it gives independence. It gives independence in terms of energy. And challenges of solar PV. Intermittent sunlight. Inconsistent sunlight affect the condensed electricity generation reliability. That is, example is when there is a rainy season, the sunlight is not available to that amount when compared to the summer season, right? So the electricity is not generated to that extent. That's what the meaning of this statement. And high initial cost. The installation and maintenance expenses hinder the widespread adaptation. That is, the initial cost investment is very high, and maintenance also a little bit high. So it's one of the challenges. And storage solutions, addressing the need of uninterrupted power supply. As I told, in the rainy season, the amount of solar energy it will not received by the solar panels as much is not received to the large extent, right? So we need batteries. Okay, that provide the continuous energy, that produce continuous electricity to the people. And efficiency limitations. Solar PV efficiency impacted by weather conditions and locations. As I told, in the rainy season or in the winter season, amount of the sunlight is received by received by the solar panels are very less compared to the amount of sunlight received during the summer season. This is one of the challenge. Okay. And land use concerns. Large scale installation may compete with agriculture or natural habitats. Sometimes to install these panels, there is a risk of consuming the agriculture land. Okay, this is also one of the challenge. And solar PV applications, residential rooftops. We can install the solar PV systems in the residential rooftops, and we can install that in the commercial and industrial areas, and we can use that in the rural areas also, which is one of the great things that we can do. And it access portable solar solutions, mobile units for camping, emergency or humanitarian aid. Okay. And let us see the feature of PV. Efficiency advances, enhancing solar panels performance through technology innovations, material innovation, developing new materials for more efficient solar cells, regulatory support, policies of promoting solar adopting and investment in incentives, and last one is a dominant energy resources. Solar PV poised to play leading role in global energy transition. And last but is the conclusion recap. Solar PV benefits the environment. It benefits the environment by reducing the greenhouse gas emission, thereby generating electricity and economic. Since it creates jobs for the people, it boosts the economy and social aspect like it doesn't produce any gases or it doesn't do any noise pollution. All those things that comes under social aspects. Urgency. Embrace the solar PV with suitable energy transition now. And environmental responsibilities reduce the carbon footprint with solar energy adaptations. Since the solar energy is utilized to generate electricity, here the electricity is generated without any emission of carbon. Right? That's the meaning of this. Economic opportunity invest in solar for job creation and cost savings. Okay, and collective actions join the movement towards renewable energy adaptation today. Thank you. If you have any doubts, feel free to write the comments in the comment section. I will be there to assist you. Thank you. Have a nice day.